All right, writing equations of lines and linear inequalities. First thing I want to remind you guys of is the three forms of linear equations. The first one is standard form, which is usually written like this. Ax plus by equals c. Or lowercase letters or whatever. An example would be 3x plus 2y equals negative 4. Okay. Then we have slope-intercept form, which is just as it sounds. We have y equals mx plus b, where m is the slope and b is the, which intercept is b? The y-intercept. So an example of sloped-intercept form would be y equals 4x plus 2/3. That's just, a random example. Sure. And then we have point slope. Form. And in this case we have y minus y1 equals m times x minus x1, where m is the slope, and then x1 comma y1 is a point, on that line. Okay. And an example of this would be y plus 2 equals 3/4 x minus 1. What would the point be in this equation?
1, negative 2.
1, negative 2, right? Because it's plus 2 and our equation calls for minus y1. So our point is 1 comma negative 2. That's our point. Now, let's think about this. For a given line, so let's say I have a line like this. How many equations could you write for this line in standard form? Would it be 1 or would it be more than 1?
1.
Why would it be 1? What's your reasoning? What's your thinking? So let me actually give you some points. Let's say this is, this would be 4. So y is 4 at the intercept. And let's say x is also 4. Okay, did one too many points.
Because there would be 1 point for
Okay.
x and 1 point for y.
Okay. And so what would our standard form look like for this line? If we have a y-intercept and an x-intercept of 4.
Oh no, you could have a bunch of points.
You could.
There's so many different.
So let's think about this. We could have x plus y equals 4. Right? If we make x 0, y is 4. If we make y 0, x is 4. But couldn't I also write an equation like this? 2x plus 2y equals 8. Wouldn't that one also work?
You could divide them by 2.
Right. And so there is like a simplest form of the standard form, but you could write more equations that fit into that form. So in it was kind of a trick question. There's kind of like both answers are right. There is one standard form, but you can rewrite it in a different way just by multiplying through by something. Okay, let's look at the same line. How many slope-intercept forms could I write for that? How many slope-intercept? Let's think about this. If it goes from 4 up here to 4 down here, it must have a point of 1, 3, 2, 2, and 3, 1 as well. Those would all be points on the line, if that helps you to think about it. So what would my slope-intercept form be of this line?
Y equals negative x
Good.
plus 4.
Yeah. So my y-intercept is 4. And then the slope is always going down 1 over 1. Or you could have gotten it just from the beginning, down 4 over 4, which is a slope of 4 over 4 is 1, but negative 1. So this is my slope-intercept form. Is there any other slope-intercept form I can write of this line? Could I multiply through by something like I did with a standard form? I can't, because slope-intercept form has to just be y. So there's really, for every line, there's only one way to write the slope-intercept form.
So couldn't the slope be different?
Right, so I guess you could write it as like y equals negative 4 over 4x plus 4. So that's, I mean, it's like a slightly different way of writing the slope. But that's going to be our form. Okay. Now point-slope form. How many ways are there to write a point-slope equation for this line? How many ways can you think of? So we have y minus, let's use this point, 3 equals negative x minus 1. That's an equation using that point, my slope of negative 1. Oh, but couldn't I write an equation using this point? Y minus 2 equals negative x minus 2. Oh, couldn't I write one using this point? Y minus 1 equals negative x minus 3. Wait, what about this point? Or this, what about this point right here? Or this one, way down here? There's like infinite ways, there are infinite ways to write a point-slope equation for any given line. Because there's infinite points on the line. Right? Now, of course, there's a couple exceptions to that rule. Right? What if we... And there's a couple cases when these forms of lines don't actually work. So, what if I have a line like this? Let's call this 5. How would I write this equation of this line? Passing through x equals 5 and being vertical. Yeah, x equals 5, right? So x equals 5 is the equation of this line. Is there a way to write that? So this is the standard form, because we have, x, our a would be 1, our b would be 0, and then 5 is c. So this is standard form. Is there a way to write slope-intercept form of this line?
Yeah.
No, because I can't write y equals. There's no, it's like 0y equals negative x plus 5 or something, but that doesn't really make sense. It's not really slope-intercept form. Right? So we just have the standard form. What about point slope form? Well, first of all, let's think about the slope of a vertical line. The slope formula is change in y over change in x, right? What is my change in x? 0. So my slope for this line is the change in y over 0, which is undefined. If I have an undefined slope, there's no way I can write a point slope form because it requires the slope right there. So vertical lines, you can really only write the standard form. And that's what makes this standard form. You can write the equation of any line in standard form. These two are really useful, but they can't express the equation of a vertical line. So okay, how about if I have a horizontal line? Let's make it y equals -2. So what's my standard form equation of this line? Yeah, y equals -2 for this line. What's my slope-intercept form? Slope-intercept form is y equals, right? So this is also my slope-intercept form, because it is y equals. What's my point slope form of this line? There's a couple options here.
Y plus 5? No.
But you can actually write a point slope form of this. So
No,
let's pick a point on my line. So like 3 comma -2 is a point on my line. So I'm going to have y plus 2, right? Y minus y1, so minus a -2 is plus 2 equals, what's my slope? Let's think about the slope formula just again in general terms. Change in y over change in x. What is my change in y on this line? If I move from here to here, how much did y change by? This, yeah, it's always going to be 0. So we have 0 over the change in x. X does change, but 0 over anything is just 0. So my slope is 0. And then it doesn't matter what's inside my parentheses, because that's going to be 0. So the point slope for this line would look really weird, right? It's basically y plus 2 equals 0. It doesn't really work. So this is the equation of a horizontal line. Y equals, that is standard form, and it is also slope-intercept form, with the m, the slope, being 0 for a horizontal line. So these are always going to be our two exceptions, vertical lines and horizontal lines. And it's important just to get them straight. Vertical lines are always x equals, they have an undefined slope, because the run is 0. Horizontal lines are always y equals, they have a 0 slope because the rise is 0. And it makes sense if you think about the meaning of slope, right? We would call this like a really steep sloped hill. This line here. That would be, we would say that's like, if we were to rate it between 1 and 10, we're skiers, right? We're going to go down this hill. We're going to say, this is a 9, right? But then if we go to another mountain and the slope is like this, oh, that's nowhere near as fun. This has got to be like a 2. And then we go to one mountain and there's just like this. Oh, that's like a 0. No slope at all. But then, what if we go to a mountain like this? Ah! Falling, right? it's not really a slope anymore. It's just a cliff. So if you think about the meaning of slope, it makes sense that this would be undefined and this would be 0. There's no slope here. And here it's like so steep that it's not even a slope anymore. It's just a cliff. It's just like a drop off. Okay. Those are our 3 forms of lines. So how do you actually write equations? Or the other thing we're going to talk about is get from one to the next. So let's say I gave you an equation like this. 3x plus 4y equals 24. What form is that? Standard form. Let's put it into slope-intercept form. So starting in standard form, I want to go to slope-intercept. The first thing that's wrong is I have my x on the same side as my y. So I'm going to subtract 3x from both sides. Now I have 4y equals, and since it's slope-intercept form, I'm going to write the x first. So I'm going to write negative 3x plus 24, even though typically I would probably have written 24 minus 3x. But this is going to look more like slope-intercept form. The other thing that's wrong is I have a number in front of y. Y has a coefficient. I'm going to divide both sides by that coefficient. We have now y equals, so this is going to be slope-intercept form. My fraction has to distribute to both terms. So negative 3x divided by 4 is negative 3/4 x. And 24 divided by 4 is positive 6. What is the slope of this line? Negative 3/4. What is the y-intercept? Close. The y-intercept would be 0, 6, right? This is my y-intercept. So 6 is where the line crosses the y-axis. Okay. Now let's put that into point slope form. How would you get an equation into point slope form? What's missing? We have the slope, we don't have the point. So how can we find a point on this line? We don't even really need to graph it. We could just think about a t-chart, right? Let's just pick something for x. I'm going to pick 4 because I like the way that 4 cancels with my denominator. So I'm going to say y equals negative 3/4 of 4 plus 6. Y equals negative 3 plus 6. Y equals 3. So now I have a point, 4, 3. Just by picking an x and plugging it in, I found a point on my line. So now I can write a point slope equation for this, which would be y minus 3 equals, I already knew my slope, negative 3/4, and then x minus, the point I picked was 4. So here's a point slope equation, and again, there's infinite point slope equations you could write for this line. So there's my 3 equations on the same line. And how would you convert going the other way? How would you convert kind of back into standard form? Let's just do one. So if I had this equation, y minus 2 equals 1/2 x plus 1. Let's just say that's my equation. How am I going to convert this? So So this is point slope into slope intercept is easier to do first. So let's do slope intercept. The first thing I need to do is distribute my 1/2. Y minus 2 equals 1/2 x plus 1/2 times 1 is just 1/2. So this side looks like slope-intercept form. 1/2 x plus 1/2, but I still need to get rid of my 2 over here. So I'm going to add 2 to both sides. Y equals 1/2 x, 2.5, or 5/2 as my y-intercept. It doesn't look great, it has a lot of fractions, but that's the slope-intercept form. There's only one slope-intercept form, sort of like Graham said, we could change the fraction. We could make it 2/4 or 5/10 or negative 77 over negative 154. But this is really my best slope-intercept form. How do we convert that into standard? Well, we're going to reverse the process again. So we want to get the x over with the y. So subtract 1/2 x from both sides. Write it in alphabetical order. So negative 1/2 x plus y equals, and all that's left over here is 5/2. And then if we wanted to, we could clear out our fraction. So we could multiply everything by 2. Each term. We get negative x plus 2y equals 5. That seems a little bit more elegant than all the fractions. So there's really just one step. Let's just go back through each one of these. Standard form to slope-intercept form. We subtracted the x term, and then we divided by y's coefficient. Right? Then to get from slope-intercept form to point slope, we plugged in to find a point. So actually I'm going to say we pick an x and plug in to find a point. And remember that x could be anything. And that's pretty much all we had to do. Then we just wrote the equation using the same slope and the point that we found. Going in reverse, to get from point slope to slope intercept, we just distributed the slope, and then we subtracted, or in this case we added the constant term. You guys remember what constant means? It's like the number on the y side. So 2 steps. To get from slope-intercept to standard form, there's really just one step. We just subtract the x term over. And then we can kind of optionally multiply by the least common denominator to clear fractions. So going between any of these forms, it's usually just a matter of 1 or 2 steps. Not too tricky. All right. Can I erase this half here? Okay. Cool. So we looked at graphs and we wrote equations. And I'm hoping a lot of this is a review, because I think you guys have done this before. We converted between different forms. what if you're given information and then you're asked to write an equation? So you're given a slope, maybe -3, and a point, maybe 2, 4, and you're asked to write a slope, SlopeIntercept equation. How would you do that? Well, we have our slope, so I know y equals -3x, but we don't have our y-intercept yet, unless they gave you the y-intercept, right? If they gave you 0, 4, then you would know the y-intercept is 4. The b term is 4. So what we can do is plug this point in here, right? 4 equals -3 times 2 plus b, and then we're going to solve for b. So 4 equals -6 plus b, add 6 to both sides, 10 equals b, and then we just rewrite our equation. Y equals, we had -3 as our slope, x plus, and now we know b is 10. And I would check that just by plugging in the equation again. Plugging in the point again. 4 equals -3 times 2 plus 10. 4 equals -6 plus 10. That's correct. That works. So the key, I think, with slope-intercept form is knowing sometimes to plug in a point in order to find your b. Does that make sense? Okay. Cool.
We have time to work on the homework.
We may have a slight amount. Probably not. So there's just one other thing I want to talk about. I think everything else is fairly straightforward. We talked about parallel lines, right? If you're given a parallel line, what does that mean?
Same slope.
Parallel. Yeah, that means same slope.
Maybe
What about perpendicular?
I forgot what that means.
The slope is the negative reciprocal. So if I had a line that's perpendicular, let's say I had y equals 2/3 x plus 5. A perpendicular line, this is the perpendicular symbol, would be y equals the negative reciprocal, so -3/2 x plus whatever, 7,900. Doesn't really matter. So sometimes you'll be asked to write an equation of a line given a parallel line. What they're really giving you then is the slope. They're giving you the slope. And the same thing goes for perpendicular. They're giving you a way to find the slope. All right. Last thing I want to talk about. Let's say you're given kind of a word problem. You know, we did things like this. Cell phone company A, just to be super generic, right? Charges $100 a month plus $1 per minute. Right? So what we have to figure out is what is the thing that's changing. Now, assuming that we're writing the equation for 1 month, the 100 is not changing. So the easiest way to think about this is plus 100. No matter what, we're going to pay $100. And then we're going to pay $1 times the number of minutes. So x represents minutes in that equation. So we're looking for like the flat fee, and then we're looking for like the variable rate. And the variable rate becomes our slope, and this becomes our y-intercept are b. Right? But what if we had an inequality? So if it said cell phone company A charges, and this is kind of a silly example, but what if they said charges at least $100 a month plus $1 a minute? Well, at least means the price will be greater than or equal to. Right? Because it's a minimum of this amount. They might charge more depending on what other fees you incur that month. So at least in this type of equation is going to be a greater than or equal to. The price is greater than this or equal to this, at least this. And then the other term that you might see is at most, which would be, in this case, less than or equal to. So that's when you would have to write an inequality. When you see words like at least, or at most, or a maximum of, anything like that means instead of equals, we're now writing an inequality. Okay? These won't be on your homework tonight. We'll talk a little more about this tomorrow. But this will be on the test coming up. So I wanted to just quickly go over that today. I'll give you your homework.